All right. Hi, everyone. Good afternoon. So we are going to have physics today, like I've already mentioned. And remember, we've been looking at vectors already. We already started that topic. And I think we are going towards the end of the topic vectors, right? And the part specifically that we looked at last time, we started looking at multiplication of vectors. And under multiplication of vectors, remember we talked about two types of products that we can get when we're multiplying vectors. That is, we can have what is called scalar product, or rather what is called the dot product. And then we also have the vector product, which is also called the cross product. Now, the other thing that we didn't mention actually is that we look at the difference between the two, all right? The difference between the two is that when you have a scalar product, what you're getting is basically a scalar quantity. It's a pure number. It doesn't have any direction. It's just magnitude alone. But when you are looking at a vector product, what you're going to get at the end when you do the multiplication, we're going to get what? You're actually going to get another vector. So when you multiply two vectors using vector product, you're going to get another vector essentially, okay? So that is one difference that is there when you're looking at a vector product and scalar product in terms of those differences. And it's very interesting. And when you look at this vector product, we looked at basically two methods, or rather I did mention two methods, of which in the last video, we looked at one of them, okay, which was the first method. And then in the other, and in this video, we're going to look at another method. But before we can probably go into that, I would want us to actually try and look at a question, okay, maybe a question to help us understand what we did last time in a bit more details. So let's try to look at a question like this. So we have physics. I hope you're able to get me. I hope I'm loud and clear. Okay, let me just admit this one into the meeting. Okay. So, all right. So let's say, given that A, the vector A is equal to 2I minus 3j, right? Okay. Then let's say plus k. And B is equal to, let's say, I plus 2j minus 4k. All right. Then we say find, but A, we say we find A multiplied by B, all right. And then B, we say we find the angle between A and B. Okay, so we want to find the angle between A and B. Now, before we can go to that, for me, I have not mastered those products, right? I've not mastered them, but so let's try to and get the products. So if we have, remember, if we have a Cartesian, a 3D Cartesian coordinate system like that, which is the right hand, right? The right hand Cartesian coordinate system. So this is K. And then this is, so this is the Z axis, and then this is the Y axis, and this is the X axis, right? So this is I, so this is the unit vector I here, and then we have the unit vector J right there, and we have the unit vector K here, okay? So let's say if we want to get I multiplied by J, okay? So want to get I multiplied by J, what are we going to get? Remember, you use what? The right hand thumb rule. So from I to J, what you're going to get is what? Is K, okay? So what you're going to get is K. And obviously, all right, because we know that A multiplied by B, I mean, let's say B multiplied by A is equal to negative A multiplied by B, right? So in other words, here again, we can simply say J multiplied by I is going to give us what? Negative K. Okay. Then let's get another one. Let's say if we have j multiplied by k. Okay, so we're moving from j to k. What are we going to get? So we're going to get I. Okay, so j multiplied by k, we're going to get I. So alternatively, or the converse we're going to have, we say k multiplied by j is going to give us negative I, right? According to the commutative law. According to that. So now, then from there we can have what? Let's look at in a situation where we have, let's say, k multiplied by I, okay? So k multiplied by I, again from k to I, so I'm going to get what? J, right? I'm going to get j. So k multiplied by I is going to give us j. Meaning I multiplied by k is going to give us negative what? Negative j. Okay, so I wanted us to remind ourselves of that as we try to work out this question that we have, okay? Because I have not mastered these things, I have not mastered these values. So it's always, for me, I always try to derive them on a separate portion. If it's a paper or something, I try to get them on a separate piece of paper, all right? So now, let's get back to our question, the question that we have right here on the board. So what do we have? Remember, we have a multiplied by b, which is going to be 2i, right, minus 3j, then plus k, then multiplied by I plus 2j minus 4k. Okay, so let's go ahead and do the multiplication. So let's look at this. 2i multiplied by I, so that is going to be 2i by I, right? I by I, and then 2i multiplied by 2j, that is going to be what? 4i by j, right? Then 2i multiplied by negative 4k, so that is going to be negative 8i by k. Okay, so the same one we were doing in the last video, but in that case we're using variables. We didn't have the exact value. So here we have the exact value, so we can easily work them out, right? So it's like we're multiplying the coefficients. We multiply, we get the exact value. So in this case, 2 by 1, the coefficient there is 1, so I'm getting a 2. And then 2 by a 2 there, that is a 4. 2 by negative 4 there, that is negative 8. And then we let the unit vectors remain like that. That is I multiplied by 8. And then after we're done with the x component in the first vector, we go to the y component. So we can now go to negative 3j. So negative 3j by I, that is going to be negative what? 3j by I, right? Then negative 3j multiplied by 2j, that is going to be negative 6j by j. Then negative 3j multiplied by negative 4k, that is going to be plus 12, right? jk, not so. And then we go to k. So k multiplied by I, that is going to be, so we say plus k by I, right? And then k multiplied by 2j, that is going to be plus 2j by k. Sorry, that is 2k by j, right? So we start with the first one, k by j. Then from there we go to the next one, that is going to give us negative 4k by k. Okay. Then from there we start trying to either eliminate. So the other thing that we also know is that I multiplied by I is equal to j multiplied by j, which is equal to k multiplied by k, which is equal to what? 0. So we know that inserting these values in our work there. So let's look at this. Wherever there is I and I, we know that it's a 0. So this is a 0. Wherever there is j and j, it's a 0. And then wherever there is k and k, it's also a 0, right? Then what else do we have? Let's look at what we have next. So this is going to be equal to 4, right? Because this is going, remember, since this is 0, so 0 by 2, that is a 0. Then 0 by 6 is a 0. 0 by 4, it's a 0. So those all those are going to go out, right? So now let's look at this part. For I by j, right? I by j, that is a k according to this. So that is k. And then we have negative 8. Negative 8 I by k. I by k. I by k. Where is that? So it's right here, isn't it? So that is negative what? Negative j. Okay. Then from there we have negative 3. Okay. J by I. J by I is negative I, negative k. Then from there we go to 12 there. So we have plus 12. J by k. So where is j by k? That is I. Then we have k by I. So k by I is j. So this is b plus j. Then lastly we have 2, right? 2k by j. So where is k by j? So k by j is negative I. Okay, that's negative, say plus 12, plus 2. Okay, 2 multiplied by negative I, right? My space there is more. Okay, then let's go ahead and simplify that. So this is going to give us what? 4k, and then negative and negative, that's a positive, so plus 8j, and then what else? Negative and negative, that's a positive, so we have positive 3k, and then we have plus 12i, right? 12i, and then we have plus j, then minus 2i, right? Minus 2i. And then here we simply collect the like terms, so we can go ahead and just work them out. So we have 12i and 2i minus 2i, so that is going to give us 10i, right? And then j, let's look at j. So we have 8j plus j there, we're going to have 9 what? J. And then we have 4k here, right? 4k plus what? 3k, that is going to give us what? It's going to give us that is 7k. Okay, so this is the new vector that is formed. Remember we said that the vector product, okay, the vector product is the product, all right, is a vector that is perpendicular to both vector A and vector B. So in this case, what it means is that if this is our vector A and then this is our vector B, then it means that this vector C, which let's call it vector C. So this vector C is going to be right here, okay, such that it's perpendicular to B and it's also perpendicular to what? To A, like that. So that's what it means. And then there's an angle theta in between A and B. So that's what it means when we say vector product. And this is the vector that we've obtained by multiplying the two vectors. Okay, so that is an example that I wanted us to look at. And then from there, we need to find the angle between what? Between A and B, right? Between the A and B. So now, let's go ahead now, right? So we know we did define mathematically. We also defined vector product mathematically. We said that the magnitude of A by B, right, is equal to magnitude of A multiplied by magnitude of B, then sine what? Sine theta multiplied by the sine of the angle between A and B. Okay, so in this case, this angle theta is the angle between A and B. So now, what we just need to find is to find the magnitude of the product that we've obtained. We also find the magnitude of vector A and the magnitude of what? Vector B. And then we'll be done, right? So let's find the magnitude of A by B. So this is going to be equal to, so this is 10 squared plus 9 squared, then plus what? 7 squared. So this is going to be equal to think let me just get my calculator nearby. All right. Okay. Let me just remove that. All right. All right. So that's 10 squared plus 9 squared, then plus 7 squared. That is giving us 330. All right. So we want to get the square root of 330, essentially. I mean 230. Okay, so that's 230. And its square root is going to give us, this is going to be 15.166. Okay, 15.166. And then let's get the magnitude of A. So magnitude of A, remember A was what? A was that was 2I minus 3J, then plus K. Then B was, what was B? That was it I, and then I plus 2J, then minus 4K, right? Yeah, something like that. So now we want to get the magnitude of A. So what is the magnitude of A? This is going to be equal to 2 squared, right? Plus negative 3 squared, and plus 1 squared. So this is going to be equal to square root of what? So 2 squared, all right? So this is just 4, and then this is 9, right? So 4 plus 9, that is 13, plus 1, that is 14. So square root of 14, right? And then what is the square root of 14? That is about 3.741. 742 actually. Okay, so round it off. Then magnitude of the magnitude of B is going to be root of what? 1 squared plus 2 squared, then plus negative 4 squared. So this is going to be, this is 16 plus 2, I mean plus 4, that is what? Plus, that is 20. That is 20 plus 1, that is 21. So root of 21. So square root of 21, that is 4.582. 582. Okay, like that. So we have obtained essentially all the other components in this formula. We have everything else. The only unknown in this case now is the angle. That's the only thing that is unknown, and that is basically what we're trying to look for, right? That's what we want to look for. So we now go back to this formula. This formula then is going to become, right? It's going to become what? The magnitude of A by B was 15.166 equal to magnitude of A. We got that it was what? 3.742 multiplied by 4.582, then sine theta, right? So this is now going to be, so we multiply there, that is 3, right? 3.742 multiplied by 4.582, like that. So this is going to be 17. So we have 15.166 equal to 17.1458. Okay, so I'm trying to leave as many decimal places as possible so that we don't distort the final answer. Remember those the syntax errors and so on. So then sine theta, all right? And then we divide both sides by 17.1458, and this side 17.1458. In other words, we're just trying to make sine theta subject to the formula, so that will cancel. We remain with sine theta is equal to what? Is equal to 15.166 divided by 17.1458, and then sine theta is going to be equal to so we say 15 0.166, all right, divided by my answer there. So this is going to be sine theta is equal to 0.8845. Okay, if we round it off to 4 decimal places, and then theta then is going to be equal to sine inverse, right? Sine inverse of 0.8845. Okay, which is equal to, so sine inverse of that, this is going to be 62.2 degrees. Okay, so that is going to be your answer. That is the angle between the two vectors that we have, between vector A and vector B. Okay, all right, so that is how you go about these kinds of questions. Of course, you may meet a bit kind of twisted sort of questions, but essentially this is how you go about it. Now I want to show you another method. Okay, probably we'll still use this same